Okay, this is part 3, thanks to a phone call right there in the middle. But what I was saying here on 53 was if you had 2 logs and that's all you had, like, and I'm looking for it real quick here, like number 43. Notice we had 1 log equal to 1 log, and it was great because we could just set what we were taking the logs of equal to each other. But that's not what we have here because of this minus 3. Notice this is not in parentheses right here, so it's not the log base 2 of w minus 3. It's a log base 2 of w minus 3. So it's an afterthought. So what I'm going to do is I'm going to move this 3 and get it all by itself. So I'm going to move it to the other side. And I'm going to take this guy and move him over here. So since it's minus on this side, when I move it over, it becomes plus. Now remember your properties. If you've got 2 logs with the same base and you're adding, I can make the 2 1 by multiplying. So that's what I've got right there. And then once you have 1 log, you can put it in exponential form. So it's going to be 2 to the third equals w times w plus 2. So that's going to give me, what, 8 equals w squared plus 2w. Set it equal to 0 anytime you have something squared. And then we're going to factor. So find factors of negative 8 that add up to 2. So that would be a 4 minus 2 gives me 2, and 4 times a negative 2 gives me negative 8. So you can see here w is going to either be negative 4 or 2. Go back in there and make sure that neither one of those give you a negative, you can never take the log of a negative. And I can see if I plug a negative 4 in right there, that's not going to work. Now I'm going to double check the 2. Okay, it's going to be fine. So that's my one answer, is that w equals 2. All right. Again, I have a log on this side and a log on this side, but I have my number over here. So what I'm going to do is I'm going to, just like I did here, I'm going to get my logs together, my constant on the other side, I'm going to do that same thing over here. Since I'm adding on this side, when I move it over here, I'm going to be subtracting. So I've got 7x minus 2, and I'm going to be subtracting log base 6 of x plus 5 equals 1. Now remember, you can take the 2 and make them 1 as long as they have the same base. But since I'm subtracting here, I will be dividing over x plus 5, and that's going to equal 1. Once you have 1 log, put it in exponential form. So it's going to be 6 to the first, which obviously is just 6, is 7x minus 2 over x plus 5. I always like to get rid of fractions, so the opposite of dividing by x plus 5 is multiplying by x plus 5. And let's just solve that real quick. If I move my 6x over here, I'm going to get x. Move my 2 over here, I'm going to get 32. And that should be it. Once again, I'm going to make sure that doesn't give me a negative up here. So I'm going to check. Good there. 32, I don't know what that is, but it's a huge number, so it's going to be positive. All right. Last one I'm going to do for your review. Good God, I have 3 logs. Make these 2 into 1, and we're adding, so I can make the 2 1 by multiplying. And then this one reminds me of number 43. When you have 1 log equal to 1 log with the same base, if they're equal, then I can just set these 2 guys equal. So I know x times x minus 7 has to equal x minus 15. So that gives me x squared minus 7x equals x minus 15. Anytime you have something squared, make it equal to 0. So I'm going to move everything over to this other side. If I subtract x from both sides, that's going to give me, what, negative 8x plus 15. It's a minus 15, so when you move it to the other side, it's a plus 15. Okay, so factor. Notice those add up to negative 8. They multiply to give you 15. So x is going to be either 5, or 3. I'm going to go back up here and check. It can't be a 5. I didn't even check the rest of it. It doesn't even matter. But it's going to give me a negative on one spot, so the 5 doesn't work. And notice 3 doesn't work either. So nothing works. So it's, you either could say it's the empty set or no solution.